Hello, my name is Ruben and in today's video we will solve the following problem. When carrying out a survey of sewage networks, Bill noticed that some elements took too long to be filled, namely the depth of the upstream and downstream pipes. However, Bill noticed that all the pipes were 1 cm below and above the bottom of the manholes. To make the work easier, Bill filled in the depth of the manholes, leaving the depth of the collectors blank, to be filled in later in the office. Since the survey has many elements, what is the quickest way to fill in the missing data? That's what we're going to find out. So, as you can see in this example, we have some sewage elements, for example, manholes, manhole secondary, collectors, collector secondary, pump stations, and sanitation plants. But for this example, we are only going to use these two, manholes and collectors. In the red dots, we have depth data for each manhole, and the idea for this video is to run tools so that we can transport this data in some way to the shapefile collectors. That is, pass data from a point element to a line element. If we open the manhole attribute table, you can see that we have the life cycle as well the conservation, z-terrain, that is the elevation value of the manhole cover, the z-bottom, it's the elevation of the bottom of the box, and as well the value of depth. Now checking the collectors attribute table, we have life cycle as well and conservation, and we want to fill these four elements, so the depth of the upstream, the depth of the downstream, the z-value of the upstream, and the z-value of the downstream, and as you can see we have no values in this shapefile. Since we have the depth data in the manhole, to know the upstream and downstream depth of the collector, we will need to remove 1 cm from the depth of the manhole for the final vertex of the collector and increase 1 cm for the initial vertex of the collector, as I show in the image that is appearing on the screen. Obviously, this type of exercise can only be done when the downstream tube is close to the bottom of the manhole. Checking once again the data from the manholes, we can see that we have some values that are not filled or are filled with 0. This is probably because some of the manholes weren't open, but we are going to work with the values that we have. So let's close this attribute table and let's start all the processes to do this, okay? We are going to start by working with the collector's shapefile, and we need to transform these lines into points, okay? And I want to convert this line into the first vertex of the collector and the last vertex of the collector. To carry out this exercise correctly, it's extremely important that the direction of all lines are correct. We cannot have lines in reverse, for example. That's why I place the arrows to confirm that all the lines follow the correct flow direction. I can see here that this line is correct, so the first vertex is a green vertex and the last is a red vertex. So to do this, let's clear the selection and go to analysis. In this arrow we are going to more tools, and let's search for the tool feature vertices, and we click on the first one, feature vertices to points. Drag and drop the collectors into the input features and then choose a location for this new file. And I will call it upstream underscore points, for example, and click save. And here for the point type, I want to start vertex, okay? So the upstream side of the collector, so the start vertex. Let's take the opportunity to do it for the downstream as well. So just change these to downstream, and the point type now it's the end vertex, okay? Let's click run. Okay. we can see that if we check the downstream, we see that the first manhole never has a downstream point. Let's check the attribute table of the upstream, for example, and these are the elements that we need to fill, and as well we have the origin feed column as well. For the second step, go to the upstream points, joins and relates, and click on Add Special Join. For the target features will be upstream points, and for the join features will be the manholes. And it's very important to uncheck these keep all target features, okay? And why is that? So since we only want to start vertex points, we don't want to join all the elements. Let's open the upstream points. Right click and open attribute table. And let's fill these values. So the depth upstream and the Z upstream as well. As we saw in the image I showed, to calculate the upstream depth, we have to add 1 centimeter to the manhole depth. Let's right click on depth upstream, go to fill calculator, and the formula is depth plus 0.01 centimeter. And for the Z upstream, go to calculate field again, and the formula is a little bit different, is Z bottom plus 0.01 centimeter as well. Click on apply, and the values are filled, but there's a little problem because there's some manholes that weren't opened. So we have this 0.01 centimeter of depth. So for the manholes that we were not opened, we need to transform this 0.01 back to 0. Let's type 0, and for the Z value or the Z upstream, we need to do the same thing. So let's convert this value back to 0. Okay, this part is finished. Right click on upstream point, go to joins and relates again, and remove all joins. Click yes. And now let's do the same thing for the downstream points. Right click, joins and relates, add special join, drag and drop the manholes for the join features. Don't forget to uncheck keep all target features. The match option, it's intersect, and click OK. Let's open the attribute table of the downstream points. And now the formula that we are going to do, it's slightly different, but it's very simple. So go to calculate field for the depth downstream, and for this will be depth, but instead of adding 1 centimeter, we need to take 1 centimeter away, so minus 0.01 centimeter. And for the Z downstream, it's pretty similar. It's Z bottom minus 0.01 as well. Click apply, and that's it. We can now remove the joins, or actually first let's see if we have this. Yes, we have. We need to transform this back into 0. Let's change this back to 0. and the Z downstream as well. Calculate field, 0, and apply or OK. Okay, let's close this attribute table, remove all joins, joins and relates, remove all joins, yes. And to finish, we just need to move these informations back to the collector's shapefile or the line shapefile. Go to the collectors, right click, joins and relates, and now we just need to do a simple join, so click on add join. And for the join table will be downstream points. Let's start with the downstream points. And let's see if we have a common field that we can use. So let's open the downstream points and the collectors as well. I like to right click here and open a new horizontal tab group, and let's select one random element, for example this one. And if we go to the selected records, we can see that these elements share the same feed, for example. So the feed of the collectors is 10 and the downstream points is 10 as well. So we can use this field to join these two tables. Let me close these two attribute tables and clear the selection. Right click on collectors, joins and relates, add join, drag and drop the downstream point into the join table, and choose feed as the common field in both tables. Okay, so the join is done, and now we just need to pass the information of the downstream points into the collectors. It's super easy, just choose the field you want. In this case, we need to pass the information back to the depth downstream and Z downstream. So depth downstream, it's equal of depth downstream of the downstream points. And for the Z downstream, it's the same. It's equal to Z downstream of the downstream points as well. So right click, calculate field, and this is equal, go to the bottom of this list and choose the Z downstream of the downstream elements. Let's remove all the joins to see the original collectors, the shapefile, and it's correct. So now we have the downstream and the Z downstream elements. And now we just need to do the same for the upstream. Okay, so just do a simple join with the feed, calculate field on the first depth upstream. So calculate field, it's the same of depth upstream of the upstream points. Let's apply. And now we need to finish with the same for the Z upstream. This one. And click OK. And that's it. Now let's check if the values we filled or we calculate are correct. Let's first remove the joins of the collectors. And let's uncheck the secondary network. These two elements as well, let's remove from the project. And what I like to do is to check, for example, 2 or 3 elements. So let's start by this manhole. We can see that this manhole have a depth of 1 meter and 7 centimeters. So the upstream value of this collector needs to be 1.008. Yes, 1.08. Let's check if this is true. Yes, it's 1.08. This manhole have a depth of 1.23, so the downstream of this collector needs to be 1.22. And let's check if it's true. Yes, and the upstream of this needs to be 1.24, and it's correct. So it seems that all the elements are correct. Thank you for watching. If you like this type of content, don't forget to like, subscribe and comment what you want to learn next.